Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So, without any further ado, let's get started. Today we are going to discuss an important topic in image processing and computer vision. And this topic relates to standard deviation matrices as it is written here. So we'll get to know about what is this in a while, and let's first read the problem statement. Consider the following 4 cross 4 pixel image with gray values in the range 0 to 8. Write the SDM image matrices corresponding to angles 45, 90 and 135 respectively. So, and we are given this image, gray values image, right? So like always when we are dealing with SDM matrices, we need to remember that it has to correspond to a particular angle, right? SDM matrices by itself don't convey any meaning. So we need to have some angles to which these matrices will point to. So SDM matrices, as the full form suggests, is standard deviation matrices. It kind of relates to how the deviation in edges are there in a particular image. Also, it is known as gray level co-occurrence matrices. You will find it as GCLM short form, and practically this is used in texture analysis. So today's topic is prevalently related to texture analysis, and this is extensively used in CNN, convoluted neural networks, and image processing and the techniques involved in that. And if you talk about the application, so these are heavily used in detecting breast cancer diagnosis along with other deep learning techniques. So the medical field uses these technologies extensively these days to kind of perform their diagnosis. So the first part of the question is basically we need to have the SDM matrices corresponding to 45 degree, right? So if we go down, we know that 45 degrees is basically exactly in the between of the vertical and horizontal, right? And for SDM matrices we will consider only anti-clockwise rotation. So what we need to do is, whenever we see the ith like in the matrix given below, let us consider the row as ith number and the j as, and the column as the jth number. So we have all these values like 0, 2, 4, 6 and 8. So they will consist of the row values and the column values. So you see the names of the rows and columns are written according to that, like 0, 2, 4, 6 and 8, 0, 2, 4, 6 and 8. So what we are going to do here is, if the number present on if the number present on I goes to j and the angle formed between is 45, then we will count it in, right? So let's go an example. So suppose we take 0 and 0. So if you see that this 0 and this 0, they create the angle 45 with the horizontal, right? So this is a particular pair, and now you see moving from this 0 to this 0, right? Let me just erase it. Moving from this 0 to this 0, we are going in 45 degrees. Similarly, if we see this direction, you know that we have this horizontal and this direction. So this is also anti-clockwise movement. So again here also it will be 45. So you see that 2 times 45 is occurring between 0 and 0. So if we take this one as I and this one as j, we get one pair that has 45 degree, the angle in between. Now if we take this one as I and this one as j, then we again have a 45 degree angle in them. So then we have 1 plus 1, so the net total is 2. So that is why you see the pair 0, 0 will have the value 2 in the SDM matrix. You see the value is 2 here. Similarly, if we check for 2 and 2, so we go above, we see that 2 and 2 are only present in horizontal. There is no angle between them, and the angle actually between them is 0. So we don't have an angle, and absolutely 45 is not there. So what we have is we will write 0 here. Similarly, with 4 and 4, we will have 0 again. If we see the matrix, you see that there is no 45-degree angle between 4 and 4, so it will be 0. And in 6 and 6 also it will be 0. Similarly, in 6 and 6, let us go above. You see again we have this particular angle 45. Similarly, when we come back, we again have 45. So it will have 2 and 0. Now we come to the first row. Okay, so we try to consider 0 as the starting point and j as the ending point, and then check whether we are getting 45 degrees or not. So if we just go above, so 0 and 0 we have already written. Let me erase the previous marks. So you see 0 to 2 is an angle, and we don't have any other 0 starting point and ending point 45. So then what we can say is it will be 1. Similarly, for 0 and 4 it is 0, 0 and 6 also it is 0. Then again we come at 0 and 8. So if we go above, we see 0 and 8 have a 45 degree. You see the 45 degree is here, right? So then again we have another value here, so we write 1. Now what we can do is we can use a simple trick here, that if we got a to b as the value x, so suppose we got the value 0 to 8 as 1, so 8 to 0 will also be 1. You see 8 to 0 is also 1. Why this? Because the angle is measured in anti-clockwise direction, and once we measure it 45 in one way, the other way will also be 45. So that's why it's 1 the opposite way, and in this way we can just simply calculate the entire matrix a bit faster. Okay, now what we need to do is like find the 90-degree angles, right? So similarly as what we did, let's first erase the marks. So first we will calculate the diagonal elements. So see, we have 0 and 0 here, 0 and 0 here, right? So you see for this pair there will be 2, for this pair also there will be 2. The same logic, because they are like, this can be I or this can be j, right? So similarly we can have both of these cases, and we will get basically 4 for 0 and 0. So if we go down, we see 6. So that means that we missed something. So if we come above, we see this one, and also here we also have another pair down here, means this one. So we can see that 0 and 0 combines to 2 plus 2 plus 2, which is 6. So then we will have 6 here. Similarly, for all of the other we have zeros except for 6 and 6. So let's see how it works. So let me erase that. Okay, so we see 6 and 6 is 2, right? And there is no other 6 and 6, so it will be 2. So that's how we calculate with 6. Similarly, let us not find each and every one, because like that will be quite easy for you. So what I'll do is I'll try to find this one, and let's say I try to find this one. So I'll find 2 and 4 and 6 and 8. So if we start from 2 and end at 4, so if we start at 2 and end at 4, we get this one, we get this one. So we have 2. And if we start at 6 and end at 8, we only get this one. So you see, for 2 to 4 we will get 2, and for 6 to 8 we get 1. So if you just check, you see we have 2 and we have 1 here. Similarly, we can find the other matrices as well, like the other values in this matrix. Now the last part is the 135 degree angle. So 135 is simply, put, like 45 angles, 45 angles after 90 degree, right? So we have a 45 here. So that's the direction which we are going to consider when we are like moving from I to J. So if we are going like in that way, so just we'll take into consider the zeros, the diagonal elements first. So you see 0 to 0, 1 and 2, then again 6 to 6, is there any pair 6 to 6? I don't think so. 8 to 8, no. 2 to 2, no. So there is only one pair, that is 0 and 0. So let's see if that is what we get. So yeah, you see that only 0 to 0 is there. Now if we see, like here is a odd one, so 0 to 6, let's see how that works. So 0 to 6, here you see a pair, here you see a pair, and here you see a pair. So 0 to 6 is 3, so 6 to 0 will also be 3. So let's see if that is what we have. You see 0 to 6 is 3, and again 6 to 0 is also 3. So this is the symmetric property of SDM matrices that is being followed. So you just need to create the upper triangular matrix which we have studied before. So like when we have this upper triangular matrix already solved out, we can just simply reflect that about the diagonal and get the values in the lower half as well. So that is how you calculate the SDM matrices for like texture analysis, and there are many applications where SDM matrices are used in texture analysis. So I hope the explanation is now clear, and still if you have any doubts, then feel free to reach out in the comment section. And if you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving. Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.